How you doing?
Good, how are you?
Good. Close my door. I got barking dogs and everything here. All right.
Okay.
So let's see. You sent me material that I've seen numerous times today already.
Oh, really?
Yeah, I have quite a few geometry students. You're at Chatfield, right?
Yes.
Yeah, I can tell from this. Where would you like to begin?
Wherever you think will be a good starting point.
Well, let's see. Usually at the beginning, I may have these backwards here. This looks like part A. Start here. Oh, we have a two-column proof even. How's your geometry class going? What are you getting in the class right now?
A C.
C. Okay.
Mainly because I was out in the hospital and I had a lot of makeup work.
Okay. Okay. You okay?
Yeah, I'm fine.
Okay. How's your algebra? In other words, it looks like we have some algebra review here. How important is that going to be to you? I assume you have a final coming up here in the next 10 days or so?
Yep, next Wednesday.
Next Wednesday?
Yep.
Okay. So we want to review that stuff for sure. But slow. Let's just review a couple of these for the heck of it because you really need to know this. What's the slope of CD?
So would we use the slope
What's the
equation?
definition of slope?
Rise over run.
Okay, and if we look at CD, what does rise mean?
3 and 4.
That's the run, actually.
Oh.
In other
So
words, when we say rise over run, think of the Cartesian coordinates. The rise is in this direction. The run is in that direction. So it's actually, I like to say, the change in y divided by the change in x. And then you can make it more complicated still by saying y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. In other words, this is really what you're going to use to calculate slope.
Okay.
But how you memorize it is important because 5 years from now, you might not remember this, but you will probably still remember rise over run. And rise over run always gets you to this. So,
gotcha.
What's y sub 2 between C and D?
Negative 15.
What's y sub 1?
Negative 7.
Okay, notice how I'm writing it. In other words, it's y sub 2 minus y sub 1. What's x sub 2?
4.
Minus 3. What's that numerator?
Sorry?
What's the numerator?
Oh, what, negative and a negative? Like that? Going to a positive?
That's correct. I can do that.
105?
No, we're not multiplying. We're adding.
Oh, my bad. So would it be 22?
Well, we have a negative 15 added to a positive 7. Negative 15 plus 7.
Gotcha. So, 3?
Negative 8.
Negative 8. My bad.
Over 1. Or just negative 8. Okay. All right. So finding the slope between any of these 7 points is going to be that exact process.
Okay.
Okay. How do you get the midpoint? In other words, let's find the midpoint between D and E. That's another one of those algebra things that you're always going to need to do.
Okay.
So it's worth our reviewing that. In other words, D is, it's exactly as you would think it is. What would you think would be the way? What's the midpoint x coordinate going to be?
5.
Uh-huh. What's the midpoint y coordinate going to be?
-8. -7.5.
No. Remember that the midpoint has to be equally distant from each of the 2 points. If it was -7.5, it would only be 2.5 away from that. It would be 7.5 away from that.
So -10?
Correct. Now, how do we get that? We add the 2 numbers and divide by 2 in both cases. You didn't need to do it for 4 and 6 because it was clear 5 was the midpoint. But -15 and -5 is a little tougher. But notice if we add those 2 numbers, we get -20 divided by 2 gives us -10. So the midpoint is exactly what you would think it would be, halfway between each coordinate. But just remember, if you add the 2 numbers and divide by 2, you'll find that. Think of it as average. That's the average point, and that's the way you get averages. Let's talk about the equation of the line BG. I kind of like that they're doing this stuff because this stuff is stuff that you're going to have to know for a long time. This is stuff that really is fundamental to a lot of math, actually. So, if I want the equation of that line, what's the most important thing? What do I need always?
Y.
Slope.
Oh.
Slope. Remember that. In all higher mathematics, that continues to be true. Slope, surprisingly, is a very, very important part of all math, right up through calculus. So,
Gotcha.
What's the slope here?
For both?
From B to G. So I'm going to take y sub 2 minus y sub 1.
19 minus a -6.
Which is 25.
And
then over what?
3 minus 2.
3 minus a -2. Don't drop negative lines because it matters. In other words, if I drop that negative sign, I get 1. But if I don't drop it, in other words, if I really put in 3 minus a -2 like I'm supposed to, it turns into 5. So my slope is 5. Okay?
Okay.
Now, the equation of a line. What's the general format that you know for an equation of the line?
Y equals mx plus b.
That's the one everybody tends to remember. Well, I know what m is. That's 5. So I can go ahead and fill that in. I don't know what b is. If I could solve for b, then I would have the equation of the line. Can I solve for b? What do I have to do to solve for b?
You have to get the y-intercept.
Well, that's b. That's what b is. But I can solve that equation as long as I have a point that's on the line. Well, I happen to have 2 points.
Oh, so we can put in y.
Hey, I can put in the x and the y value for x and y, and then I will have an equation that I can solve for b. Okay?
Gotcha.
So let's use this point over here. Normally I like smaller points, but I'm going to use this point because they're both positive numbers.
Gotcha.
And I like positive numbers even more than I like small numbers. So I'm going to plug in 19 for y. I'm going to plug in 3 for x. And now when I solve for b, I get b equals 4. So now I'm just going to take that equation, change 4 for b, and there's my equation of the line. In other words, your final equation is always going to have a y and an x in it. And is all I'm trying to do is solve for what the m and what the b is. And this is the best way to do it. In other words, solve for the m first, it gives you slope, and then choose either point, substitute it into the equation that you now have, and that will allow you to solve for b.
Gotcha.
All right. What was the slope of BG? It was 5. Which of these equations is perpendicular to BG?
Would it be B?
Yeah. In other words, if it's the same slope, it's parallel. This line here is parallel. If it's the negative reciprocal, you have to do 2 things to get perpendicularity. You have to not only flip the slope, make it go from 5 to 1/5, but you change its sign also. So a slope of minus 1/5 would be perpendicular to a line that has a slope of 5. And we talked about parallel. C would be parallel to BG. All right, let's go to proofs. Everybody's favorite. So we have those givens, which is basically this line here is congruent to this line here, which we can tell because they both have a single hash mark. And MQ is congruent to PN. They both have a double hash mark. Prove that angle N, this angle here, is congruent to this angle here. List both givens as step 1 of your proof. Okay? So what goes here?
MN is congruent to PQ, and MQ is congruent to PN.
Okay. MP is congruent to itself. You remember which property that is?
Reflexive.
Very good. These are the kind of proofs I love. In other words, where they give you one of the columns. They don't make you figure out both columns. These aren't that tough. Okay? In other words, I can kind of figure out what the next statement has to be because they give me the reason, SSS. What's this statement going to be?
M and P congruent to PQM?
Yes. In other words, whenever you see these 3 letters, SSS or SAS or ASA, it's always a postulate proving congruency. And so now I'm able to say that this triangle is congruent to that triangle because I have 3 sides that are congruent. And finally, angle N is congruent to angle Q because
Uh, would it be CPCTC?
Very good. Hold on. How many sides does a nonagon have?
9.
What's the total sum of the interior angles? Remember that formula?
Yeah. Would it be 1,260? I think it's.
7 times that?
But don't you subtract 2? It's n minus 2.
Right, that's why. In other words, it's 9 minus 2, and
Yeah.
that's why I wrote 7 there. Yeah.
Gotcha.
The formula is n minus 2 times 180. So whatever n is, in this case, n is 9.
Gotcha.
Okay, that's good. You remembered that. I don't think we need to do some of these. It's not. Do you have a calculator in front of you?
I do.
How would we do 18?
Find the number of sides of the period.
In other words, the difficulty in 18 is, what's the equation? How am I going to solve for the number of sides?
Would you divide that number by 180?
Give me an equation that I can solve.
14,580 divided by 180.
Hold on. That's the sum of the angles, right?
Right.
Well,
Or
we know
times
that to be what?
N minus 2 equal, or times 180.
Okay. There's our equation. And our goal is to solve for n.
Mm-hmm.
Well, what's the first thing I want to do?
Would you get n and 2 out of the parentheses?
You know, I can do that, but that just makes extra work. Why don't I get rid of the 180 first?
So divide both sides by 180?
Yeah. Notice that kind of saves a step. What's that number? If you have a calculator?
Yeah. 81.
So what is n?
83?
Uh-huh. And see why we divided first?
Yes.
Notice that if I decide to get rid of the parentheses first, which is often what I like to do, I got to multiply this. So I got to turn this into 180n minus, now I got to multiply those two numbers. And now I just have I have to add that to this big number, and then I have to divide by 180. There's a lot more work. So when you see a problem like this, don't automatically distribute, even though I generally tell people that the order that I pay attention to when I'm solving algebra equations is I generally try to get rid of denominators and then parentheses. But in this case, not so.
Okay.
Easier if you divide by the multiplier. In other words, if I can get rid of that 180 instantly, why not do it?
Mm-hmm.
Okay. All right, let's go to the next page. That's this one, right?
Yep.
Is this your copy?
Yes.
Okay. I think I have a better copy of that. How would we do 21? Actually, you know what? Let me. I've been through this page before. Let's do
mhm.
the hard ones first.
Okay.
Let's do the ones you're most likely to get on a quiz.
I already did 44.
Okay. Let's go through these, and then when we have extra time, we'll go back and do the word problems.
Okay.
Okay. How do we solve x?
Well, so we would say 4x minus 21 equals 1080.
Not quite, but you're close. In other words, you figured out that the sum of the angles is 1080. What's each angle?
Oh, 4x minus 21.
No. In other words, I know how many angles they are, and they're all equal to one another because it's a regular octagon.
135 degrees.
In other words, we have to divide that by 8. In other words, the measurement of each angle is n minus 2 times 180 divided by n. That's actually the formula for the measurement of each angle. Okay, well, we know it's 8, so I can fill in the 8 to get 1080 and 8. And now I know each angle is 135. So now what equation can I write?
4x minus 21 equals 135.
Yeah. All right, 41. What is that figure called?
Kite.
Correct. Kite might be the easiest figure to recognize in all of geometry because it looks exactly like what it is, right?
Right.
I mean, it looks like a kite. So if you see something that looks like a kite, smells like a kite, acts like a kite, it's a kite. Okay. Notice that a kite is not a rhombus. There are not 4 equal sides, but these 2 short sides are equal and these 2 long sides are equal. And the other thing about a kite, what's true about the angles? In other words, first of all, let's look at what they're asking about here. Are they asking about angles or are they asking about lengths of sides?
Angles.
Correct. And normally they'll put degrees when they're talking about angles. And sometimes it's hard to tell. If it's a small figure and they don't have much room to type in, you won't be able to know whether they're talking about sides or angles, and so they'll put degrees with the angles, but they didn't do it here. But this clearly is the angle, which means they're talking about angle there and there. What do I know about this 4th angle right there?
It's congruent to 4x minus 9.
So we can label it 4x minus 9. Now I know all 4 angles in terms of x. What do I know about the sum of the 4 angles?
Adds up to 360.
So the equation, piece by piece, is
4x minus 9 plus 2x minus 8 plus 4x minus 9 plus 5x plus 11 equals 360.
You're good. That's going to allow you to solve for x. In other words, now you have one equation and only one variable, x, and so you can solve for it. Notice that the opposite angles here are equal, but these opposite angles are not equal. In other words, I could not solve for x by setting that equal to that, because you can clearly see they're not equal.
Mm-hmm.
The only other interesting thing about a kite is the diagonals. The diagonals are perpendicular to one another, and one diagonal bisects this one, but the other does not. In other words, this diagonal does not bisect that one.
Mm-hmm.
All right. 42. What principle are we going to talk about with 42? What principle are they testing with 42?
The oh, bisector.
Well, not quite. Similarity.
Oh yeah,
In other
similarity.
words, we have two similar triangles here. This triangle is similar to the big triangle. It's not similar to this trapezoid, but it's similar to this big triangle here. Why? Well, because this line here bisects both side EB and DB, that makes this line parallel to this line. And the fact that this line is parallel to this line makes this angle the same as that angle, and makes this angle the same as that angle. In other words, whenever you have parallel lines, these are transversals, and those are corresponding angles, so they're equal. And B is equal to itself, right?
Right.
So we have all three angles equal. Now, one thing that I find particularly helpful when I'm looking at similar triangles is to draw them separately, like this. This is my triangle ABC, and this is my triangle EDB. Okay? Now let's go ahead and orient our angles that are the same. So, because it's one thing drawing it in proper perspective, but a lot of times these things can be upside down, right? In other words,
Right.
they may give you a problem where this thing is drawn upside down and they tell you the two triangles are similar, and it's not immediately readily determinable which angles are equal to one another. When they're oriented exactly the same way, like I have them drawn now, it's pretty easy to tell D is equal to C and E is equal to A and B is equal to B. But one way, once you define which angles are equal, even if it's not drawn properly, then you take the side opposite. In other words, let's say I had this drawn upside down. Well, which side is the corresponding side to DB? It's the side that's opposite that angle. So even if I had this rotated 90 degrees and drawn upside down, I merely need to find the side that's opposite that angle, and that's CB.
Gotcha.
Okay, so that's the best way to determine your corresponding sides. And that's the most important thing you generally want to know. Well, this side is 15. How long is EB?
EB. EB's 30.
Okay. Now, is that enough to come up with a linear ratio or a similarity ratio, whatever you want to call it? Yeah. In other words, that's the corresponding side of this. So whatever this ratio is, the same ratio has to exist between this side and this side, or this side and this side. That's the thing about similar triangles, is the ratios of their corresponding sides are the same. Okay? So how long is DB?
DB is 28 centimeters.
So how long is CB?
14 centimeters.
And this is 4x minus 8. So how long is AC?
2x minus 4.
Good. And they tell me the perimeter of this thing is 39. What's my equation I can write to solve for x?
You can do 39 is to...
not a ratio, it's an equation.
Oh.
Well, a ratio is an equation also, so it's not fair to say that. But there's no ratios involved because they're telling me the perimeter. What's the formula for perimeter? What am I going to do to get perimeter?
Length times width times height.
I'm going to add up the three sides. The perimeter is the measurement around a figure. It's the same as circumference. The circumference is the perimeter of a circle. Okay? So the perimeter of a triangle is the sum of the three sides. Well, my three sides here, there's one of them, plus 15 plus 14 equals 39. And again, I have one equation and only one variable, so I'm going to be able to solve for it easily.
Gotcha.
Okay. What kind of figure is 43?
A rhombus.
What'd you say?
Rhombus?
When I think rhombus, the first thing that comes to my mind is 4 equal sides. And that, in fact, is the definition of a rhombus, is 4 equal sides. Is this 4 equal sides?
No.
No. Doesn't look like it, and they don't tell you that it is either. In other words, if that was a rhombus, they would have a hash mark there, 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 and there. So what else is it? Could it be? What other term? It's a quadrilateral, but it's also a special quadrilateral. What is that?
Parallelogram?
Yeah. Parallelograms, the definition of which is two sets of opposite, parallel, and equal lines. Well, we have one set here, and we have another set here. And they are not just parallel, but they're equal. And what do I know about parallelograms? What's the relationship between that angle and that angle?
They're congruent.
Correct. And this angle and this angle.
Congruent.
And this angle and this angle.
Supplementary.
Good. So what's the equation?
5x plus 20 plus 3.
Plus 3x.
Equals 180.
Correct. Again, in other words, most of geometry also has that algebra step in it. That final step to solve for. Okay, 23 is multiple choice. We have to pick one of these words to fill in for each blank. Okay.
Well, 38 and 39. 38 is parallel and 39 is a kite.
Okay. That's pretty good. How'd you get so far ahead of me?
I don't know.
Okay. How about 23?
23. A polygon which is interior. Full measure is 120. Would it be a parallelogram?
First of all, it's a polygon, which generally they're referring to something that has so many sides.
Mm-hmm.
Okay. And we know the interior one angle. Well, remember, what's the equation? M minus 2 times 180 divided by what to get one angle?
N.
Okay. That's equal to what here?
120.
Now we have to solve that equation to figure out what n is. Okay.
Oh, gotcha.
What's my first step?
Multiply each side by n.
Yeah, let's do that first. Now my second step.
Divide
Good.
each
Divide
side
by
by 1.
180. Not quite as useful as it was before, but it's still going to save us a step. In other words, it gets rid of that. We don't have to spend the time distributing that 180 to those two terms. Well, 12 over 18 is the same as 2 over 3. So I can reduce that to that. And I have n minus 2 over there. I apologize. Let's go backwards here. What am I thinking? This is different. In other words, if I divide both sides by 180, I've got n on the left and n on the right. And from this stage of the equation, my next goal is to really gather everything with n in it on one side and everything with numbers in it on the other. Okay? Well, I can't do that by dividing by 180. So because I have an n on the right side, last time we had this problem, we just had a number over here, a big number, number 14,000 something. The fact that we have n over there, we do need to distribute this. In other words, the way to solve this is to take this step, and you'll see why. Now I can gather my n's together. I'm going to bring this 120 n over to here, leaving 60 n. I'm going to take the 360 over there. Now I can solve for n. It's a six-sided figure.
So,
Oh,
the hexagon.
yeah, a hexagon, yeah. The altitude from the vertex angle in an isosceles triangle is also the,
Angle bisector.
correct?
And the adjacent.
I think it means altitude is also the angle bisector and altitude. I don't see anything else here that's going to fit that second word. It's not complementary. It's not adjacent. It's not equilateral. It's the altitude. It's not any of these. Oh, it's also the median. Yeah, remember what a median is. Median is when you go from a triangle, you go from any vertex to the middle of the other side. That's a median. Well, when you have an isosceles triangle, the altitude is the median. It goes to the middle of the other side. You know, if these two sides are the same, so this is angle bisector and median. Linear angles must be supplementary and
supplementary.
That would be a hard one to answer if I didn't have this list of things to choose from. I wouldn't have a clue of what else they must be. But looking at that, you can probably find it.
What is?
Here's what they mean by linear angles. 1 and 2 are linear. So we know they're supplementary. What else are they?
Adjacent?
Uh-huh. Okay. This line and this line are
parallel.
No, they don't have the same slope.
Oh, my bad. I thought you were talking about the lines on the paper.
Oh, that's funny. Yeah, they are all parallel.
Perpendicular?
Yeah, because this slope is the negative reciprocal of that slope. Consecutive angles in a parallelogram are?
Complementary.
Uh-huh. A rectangle is what kind of a parallelogram?
In equiangular. I can't say that word.
Yeah, I think that's the answer. Oddly enough, when I did this earlier in the day, I was just picked out a couple of problems to do, and I thought perpendicular was the answer. But we already used perpendicular. Perpendicular definitely is the answer here. So equiangular probably is the answer here. Equiangular means that there's 4 equal angles. And most parallelograms don't have 4 equal angles. In other words, those parallelograms that are kind of slanted like that, you know, this one's equal to this one, but they're not equal to that. They're supplementary. So an equiangular parallelogram would have to be a rectangle. And they're all right angles. And a rhombus is what kind of a parallelogram?
An equilateral.
Yeah. A square is what kind of a parallelogram?
Regular?
Is that the best answer we can find on there? Maybe.
Because it's both equiangular and equilateral.
It's true, it is. So it's definitely regular, but I would call it a regular polygon. I'm not sure I would call it a regular parallelogram, but I guess so. That's true. And a rhombus would not necessarily be a regular parallelogram because the angles wouldn't be the same. So okay. The sum of its angles add up to 900 degrees. She misspelled that. That's supposed to be angle. That's supposed to be angle. Then the polygon is what?
Heptagon.
So you did n minus 2 times 180 equals 900. Now here, see, the best first step is to divide by 180 because I don't have any ends on the right side. You see the difference?
Right.
In other words, I can immediately get the left side down to that and the right side down to that. And now, piece of cake. But if I stick an N over there, I can't do that. Then I have to distribute it in order to gather the ends in the same place. A polygon in which each exterior angle measures 30 degrees is what? How many sides?
Dodecagon.
Good, because you knew that the sum of the exterior angles is 360, right? No matter what the polygon is, the sum of its exterior angles is always 360. Triangle, square, 20-sided figure, doesn't matter. So this has to be 12-sided. Polygon that has 2 congruent sides that are consecutive and distinct is a
altitude.
No, an altitude is what you drop from a vertex. In other words, an altitude is a vertical perpendicular. That's what an altitude is. Polygon that has 2 congruent sides that are consecutive. Well, there's 2 sides that are consecutive and the same. And distinct. I'm not sure why they put distinct in there. There's the rest of that polygon. Notice that kite has 2 congruent sides that are consecutive. It has 2 of them. In other words, it has 4 of them, but it has 2 pairs of them. It's actually hard to describe a kite. I have found it difficult to actually describe it, other than saying you have two sides, adjacent sides that are equal, and you have two pairs of them. So I'm pretty sure that's a kite. Haven't used that yet, have we? No. Base angles of an isosceles triangle are...
Well, actually, we used kite for 39.
I'm sorry, what?
We used kite on 39.
Ah, that's where we used it. So what is 33? A polygon that has two congruent sides that are consecutive and distinct is a...
Oh, would it be an angle bisector?
No. Wow.
A median?
No. In other words, they're looking for the name of a quadrilateral or some polygon. And
Trapezoid?
in other words, that's not the name of a quadrilateral, nor is that.
Oh.
In other words, a lot of these words aren't going to apply. So, dodecagon is how many sides?
12.
Okay. That actually it fits, doesn't it? In other words, if I had a regular, well, only if it was a regular dodecagon, so it doesn't fit. But if you actually had a regular dodecagon, you would certainly have two sides that are congruent, but you'd have 12 sides that are congruent. So it wouldn't make sense to say that. And it'd have to be regular anyway. Trapezoid does not have two sides that are congruent, that are consecutive. Has two opposite sides that are congruent.
Consecutive, is that like...
Next to one another.
Oh, okay.
In other words, if I drew a figure like this side is consecutive to that side. Not consecutive to that one. So, in other words, kite fits the definition, but I agree. 3, 3, 3, 3, 3, 2. There's 17. There's 17 blanks. Actually, there are 18 blanks and 17 choices. Right?
There are 17 blanks.
Well, if you subtract 39 minus 23, you get 16, but you have to add one. So there's actually 17 questions here. And one of them has two blanks. So there's 18.
Oh, right.
There's 18 blanks, and there's only 17 questions. So we're going to have to use one of these words twice, and kite would appear to be the one. Kite's going to go there and here.
Gotcha.
The base angles of an isosceles triangle are what?
Congruent?
Yep. Angles are what if they sum up to 90 degrees?
Complementary?
A quadrilateral with exactly one set of parallel sides is called a...
median?
Again, that's not the name of a quadrilateral. A median is the line that you draw from the vertex of any triangle perpendicular to the opposite side. That's what a median is.
So it would be a trapezoid?
Yes, trapezoid. I'm sorry, I didn't quite hear what you said. And Trapezoid has exactly one pair of opposite parallel sides, and only one. In other words, I don't think that is a trapezoid. It's a parallelogram. In other words, it has a pair of opposite sides that are parallel, but it's got two of them. That's also parallel to that. So I don't think, I know I could be wrong on this, but I don't think a trapezoid could also be called a parallelogram. I mean, I don't think a parallelogram could be called a trapezoid. That's what I meant to say. You know how a square is a parallelogram, but a parallelogram is not a square? You know what I'm talking about? In other words, each of these is a subset of the others. A rhombus is a parallelogram, but a parallelogram isn't necessarily a rhombus. Well, I'm not sure that applies with trapezoids. I think the definition of trapezoid is exactly one pair of opposite parallel sides. One and only one. A perpendicular line segment from the vertex of a triangle to the opposite side is a
altitude.
Median. No, you're right. Altitude is correct. Wow. I just defined it wrong to you 2 seconds ago. I drew that triangle and I said this was a median. But I was wrong. That's the altitude.
Isn't a median the midpoint of one side?
Yeah, the median goes to the midpoint of the other side. It's not perpendicular to it necessarily. This line and this line are
parallel.
Good. Well, I hope you have a quiz tomorrow because you seem to know this stuff pretty good.
I don't think so. This is 1 out of 5 sheets we're going to get for the test on Wednesday.
Oh, this is just review material for your final?
Yeah.
This is just the start of it?
Yep.
But you don't have any quizzes between now and your final?
No, just this.
Well, I'm glad I didn't know that, and I'm glad we reviewed the algebra now.
Definitely.
Yeah. No, that's definitely something that we want to make sure we don't want you messing up on the algebra part of the geometry test.
Right.
So it's good that we reviewed that. Connor, you have any last concerns, questions?
I don't think so.
Okay. Well, I guess we'll just wait until we get the rest of your materials.
Okay, sounds like a plan.
Good to go for tonight, I guess. Have a good one. I'll talk to you next time.
Okay, take care.